Dear students, today in this particular lecture we are going to discuss about mean deviation and standard deviation. So here we start. First of all, what is mean? Mean or arithmetic mean for a set of data is simply sum over the data divided by the number of data values. Suppose x1, x2, xn are n numbers in a given set of data. Then mean will be sum over all these x values divided by the number of values. For example, let me show you this. Say in a project, the height of 5 cats are found to be 60, 47, 30, 43, and 20 mm respectively. You have to find mean. So mean is denoted by x bar. What are the data? This 67 you can call it x1, 47 you can call it x2, x3, x4, x5. So you sum up all these 5 values, and how many values are there? 5 divided by 5, you will get mean. So that is how mean or arithmetic mean or average is calculated for a set of data. Next, if you have a frequency distribution, how will you calculate mean? What is frequency distribution? In a frequency distribution, you have a variable like x1 and it occurs for a certain number of time. Like x1 value occurs for f1 time, x2 value occurs for f2 times, and so on. Then under such condition, arithmetic mean or mean is defined as sum over fi xi by sum over fi. What is xi? Xi is any of the values of these x1, x2, x3, etc. multiplied by this corresponding frequency, that is fi is the frequency of xith data, and then summed over this product, divided it by the total frequency. In such a case, the mean comes out to be sum over fi xi by sum over fi. Okay, let me see if there is an example available here. Maybe possible. Let us see. Yes, we have an example. For example, here you have fi frequency 1 for the value xi 5. For 3 you have 15. For 4 you have 25. That is 25 is xi value, its frequency is 4. For 35 the frequency is 2. Then you take product of fi xi, sum over fi xi comes out to be 220, and sum over fi, total sum of the frequency is 10. Then mean will be sum over fi xi by sum over fi, which is coming out to be 220 by 10 equals to 22. So this is how you are going to calculate mean for a frequency distribution system. For example, is this one. One more example. Suppose we have pepper salt versus frequency. On 18 you have 2, 19 you have 0, 20 you have 4, 21 0, 22 2. You can have different sets of data, and you can have one x value and one frequency value. Moving on, let us go to our next definition. We have already try to explain mean. Next, we'll discuss mean deviation. What is mean deviation? It is the mean of the absolute values of the deviations of a given set of numbers from their arithmetic mean. A dot m here represents arithmetic mean. As you see, it clearly indicates that first you have to find absolute values of deviations from arithmetic mean, and then you take average of those absolute values of deviation. Let us see how it is. Suppose xi is the ith data value for a system of capital N number of data, that is x1, x2, x3 up to x capital N. Then your mean deviation is 1 by capital N, sum over capital I goes from 1 to capital N, absolute value of xi minus x bar. Xi is your ith data value, x bar is the mean of all those data. You find xi minus x bar, that is, you will find x1 minus x bar. Next, you will find x2 minus x bar. Then you will find x3 minus x bar. You keep adding them till the last one, that is xn minus x bar, and you divide it by capital N. Then you will get mean deviation. Very simple. Next, we try to find mean deviation for frequency distribution. Suppose fi is the frequency of the variable xi. Then you will find xi minus x bar. X bar is your arithmetic mean. You have to find it previously. Then xi minus x bar, you find the absolute value, multiply with fi. The product is summed over all the I, that is I goes from 1 to capital N, whatever it is, divided by sum over fi, that is your total frequency. By this way, you are going to get mean deviation for a frequency distribution. So this is all about mean deviation. Next, we'll move on to standard deviation. What is standard deviation? Standard deviation and mean deviation, they are one kind of deviations of the data from a centralized value. Mean is interestingly measure of central tendency, and mean deviation, standard deviations are in statistics generally used for measuring deviations of a set of data from a central value. One of the useful measurement in statistics is standard deviation. How will you calculate standard deviation for a set of data? So standard deviation is defined as the square root of the mean of the squares of deviations from their arithmetic mean. If you see the definition of the mean deviation and standard deviation, there is a difference. One difference is that a square root is coming, and another difference is that you have xi minus x bar square. There you are taking xi minus x bar, or here also you are taking xi minus x bar absolute value. Now instead of absolute value, you are taking xi minus x bar just without absolute value, but you are squaring it and multiplying it by fi, dividing it also by sum over fi, then taking square root. Here I could have written sum over fi, but here only sum over f is written. So standard deviation sigma is a square root of sum over fi xi minus x bar square divided by this sum over fi. This standard deviation can be found out by using a shortcut formula. The shortcut formula is square root of sum over fi di square by n minus sum over fi di by n whole square, and here your di is xi minus a. This xi minus a is actually your di here. Xi means ith data value for x, and di you can say a difference between xi and a. What is a here? Is a. How will you get a? This I will show you by using a problem, by using an example. Here we will avoid how this formula comes, but we'll show you usefulness of this formula. In examination you can use as this formula for your benefit, just like this main formula. This second formula if you use, you will be doing less calculations as compared to the first formula. For a frequency distribution system in statistics, the second formula is recommended for calculation of standard deviation rather than the first formula because of simplicity of this. A, you can, I will tell you that it's like an assumed mean. So I will show you. Let us move on. Then we have for n values, that is if you have only a set of data, not a frequency distribution table, then your sigma, which is your standard deviation, is simply square root of xi minus x bar whole square summed over I goes from 1 to n divided by n. That is, you will find out xi minus x bar whole square, and for all the set of values divided by n, take square root. Xi is what? Ith data value, and x bar is your arithmetic mean of the set of data. It is applicable when you do not have a frequency distribution, only data values are given to you, you will use this. And in frequency distribution, this formula can be used to obtain standard deviation. Done. So now we'll move and we'll try to show you some problems of standard deviation which came in your previous year question papers. I repeat that mean deviation, mean and standard deviations are not directly as a part of your syllabus. Somehow the question setters are asking these questions in 4.1. Ideally, they should be asking questions on mean and standard deviations of those frequency distributions, particularly Gaussian distribution. Okay, so we'll try to find standard deviation of measurements of 5 cats. In a project, the height of 5 cats are found to be 60, 47, 30, 43 millimeter and 20 millimeter. You are asked to find standard deviation. How will you find standard deviation? First of all, you have to find mean. So here mean is x bar, which I already explained how to find. It is sum of the numbers divided by number of values available, which is 5 here. It is coming out to be 40. This system has only data values and you have to find standard deviation out of it. So it is not a frequency distribution. Then which formula we are going to use? We are going to use sigma equal to square root of 1 by n, sum of our I goes from 1 to capital N, xi minus x bar square. How will you find xi minus x bar? It will be 60 minus 40 whole square. Next data is your 47, 47 minus 40 square, 30 minus 40 square, 43 minus 40 square, 20 minus 40 square. Last data is 20. So we are taking xi minus x bar square in this line, and divided by 5. Then after you take square root, this is the value. It will be just there, 13.84 is the value. You have to find the standard deviation of another problem. Here you have class interval 0 to 4, 4 to 8, 8 to 12, 12 to 16. You are also given the frequency values 4, 8, 2, 1. It was asked in 2014. For this frequency distribution, you are asked to find standard deviation. For simplicity, I have arranged it in a tabular form like this. Class interval is 0 to 4, corresponding frequency is 4, 4 to 8, frequency is 8, 8 to 12, frequency is 2, that is, and you have 12 to 16, frequency is to be 1 here. What is x? How did I find x to be 2 here? I took mean of 0 and 4, which is your 2. Mean of 4 and 8 is 6, 8 and 12 is 10, 12 and 16 is 14. You have a gap of 4 here. What about A? Why did I choose A here? If you look at this line, you have 1, 2, 3, 4. Out of these x values, anyone, that is either 6 or 10, is assumed to be A. I can take either 6 or 10 to be A. It is one kind of assumed mean, you can say. Here you have even number of rows, 1, 2, 3, 4. If we had odd number of rows, then you could have got the exactly middle row. From top and bottom, you have to find which one is the middle row. Then you will take that line and the corresponding x value as A. Here we have two possibilities. Either we could have taken 6 or we could have taken 10. You will find interestingly the result will come out to be same. Anyways, so A is chosen as your 6 here. That D value is x minus A. X minus A, yes, our A is 6 and this is 2. So 2 minus 6 is equal to minus 4. So that is coming here as D. Then this one is 0 because it is 6 minus 6. Then you have 10, 10 minus 6, which is your 4. Then you have 14 minus 6, which is your 8. Then you find FD, that is this D value multiplied by F. This is our F and this is our D value. Then 4 into minus 4 is 16. Other values are also found out by the product of F and D, and find out sum over FD. Here, interestingly, sum over FD turns out to be 0. Then you find sum over FD square, that is D square here is your 4 square, which is your 16. 16 is multiplied with your 4 here, that is the result is 64. Likewise, you have D square, that is here you will have 4 square and then it is multiplied with 2, then you are getting 32. Likewise, here you are getting 64. So sum of this value, sum over FD square, which is coming as 160 here, sum over FD is 0 and sum over total frequencies is your 15. Here you see, assume A is equal to 6. Then standard deviation formula tells that root over sum over FD square by n minus sum over fd by n whole square. Sum over fd square by n. Sum over fd square. You will find that sum over fd, which is your 0. So this part turns out to be 0. This has no contribution. And this sum over fd square is 160. And capital N means sum over f. N is your total frequency, which is your sum over f. So sum over f is 15. 160 by 15. You take square root and then you are getting this, the result, sigma. So this is done. This is for your standard deviation for a frequency distribution. Another problem, a recent problem. This I intentionally did not do by using the previous formula, that is your sum over fd formula, the shortcut formula by assume mean. Let us try to do it directly. In this particular case, you are given as the measurement and the corresponding frequencies were provided in tabular form in the question. 0 to 10 1, 10 to 23, 20 to 34, 30 to 42 is your frequency, and the xi values I calculated myself by taking mean 0 to 10. That is what is done usually in frequency distribution table. 10 to 20 will be 15, 20 to 30 is 25, 30 to 40 is 35. You take fi xi, just multiplication of fi and xi, 1 into 5, 5, 45 here, 100 here, 70 here, make sum over fi xi. Why do you need sum over fi xi? For calculating mean. Sum over fi, which is your capital N or total frequency, is 10 here. X bar, that is mean, is found to be sum over fi xi 220 divided by 10, which is your 22. Then you find xi minus x bar. So how will you find xi minus x bar? To find xi minus x bar, you have this 5 and 22. 5 minus 22 is minus 17. 15 minus 22 is minus 7. 25 minus 22 is your 3. 35 minus 22 is 13. Make xi minus x bar whole square. That is your 17 square here, 7 square here. It becomes positive. 3 square, 13 square. Next, you multiply xi minus x bar square by fi. So fi is your 1, then it will lead to 89. Here you have 3, then 3 into 49. Then you have 4 into 9, then you have 2 into 169. Take sum of all these, which comes out to be 810. Then your answer is almost coming up. You have sum over fi xi minus x bar whole square coming as 810. Divide it by sum over fi, which is your 10. Take square root and you will get your value to be 81. 81 square root is 9. That is your answer. This one, this alternative arrangement which I have shown here, that also you can use. Here the data values were small, so the calculation was not large, so I use this. And here this problem as an exercise, this 2014 problem, you can also try it directly by this alternative, that is this direct formula, sum over this fi xi minus x bar square by sum over fi formula. You can try it directly, and this is your compact formula. So with this we come to conclusion of today's lecture. What we learned today? We learned mean, we learned mean deviation, we also learned standard deviation, and some of the numerical problems. We did not go detail statistics because that is not part of your syllabus.